All right, problem 6.6 says determine an expression for the vorticity of the flow field described by V equals a negative xy cubed in the I direction plus y to the 4 in the j direction. Then it just asks, is the flow irrotational? All right. So first, let's go ahead and try and find our expression for the vorticity. Okay. So the vorticity, we gave the symbol little zeta, was equal to del cross V. Okay? And that is equal to partial of W with respect to Y minus partial V with respect to Z in the I direction plus partial U with respect to Z minus partial W with respect to X in the J direction plus partial V with respect to X minus partial U with respect to Y in the K direction. Okay? So this is a two-dimensional flow. There's no K dimension for our velocity. Therefore, W is 0, so that term goes 0. All the gradients with respect to Z also go to 0 because there's no third dimension. So we find out that our vorticity is just going to boil down to partial V with respect to X minus partial U with respect to Y, and that will be in the K direction. All right. So we need these two terms. This guy, the derivative of V with respect to X. So V is equal to 4 squared. Y to the 4. So that y to the 4, the derivative of that with respect to x is just equal to 0. So partial v with respect to x is equal to 0. Okay? And then this term, du dy, u is equal to a negative xy cubed. So the derivative of that with respect to y is minus x times 3y squared. All right. So we'll plug this in, and we get that our vorticity is equal to 0 minus a negative 3x y squared in the k. So that's just equal to 3xy squared in the k direction. Okay. Then it says, is this flow irrotational? So for flow to be irrotational, the vorticity has to be equal to 0. So the vorticity has to be equal to 0 for every point within our flow field. So let's see. Our vorticity in the k direction, does that equal 0? Well, it only does for certain points, but not at every point within our flow field. So because we have some component of vorticity, we then say that our flow is rotational. Okay? And that's because this does not equal 0. Okay?